Good evening, one and all. My name is Priya, and my one of the teammate name is Sahaja Priya. Um, Today we are discussing about comparative analysis of search algorithms, and yeah, coming to the abstraction. Today I'm covered this information search and uninformation search algorithms and the shortest path algorithms. We would like to talk about introduction slightly. Coming to the introduction, AI is a concerned methodologies, and this in this AI we can so I mean problem solving approaches like BFS and DFS, USC and A star algorithm and best for such algorithms. These terminologies used in today artificial intelligence. And coming to the search algorithm approaches, search algorithm approaches are divided into two categories, and one is the uniform research, and another one is informed search. Uninformed search is nothing but it's take a time and space and more complexity, and it is also search for without any information, and also there it takes no so much of memory space, and this is all default and uninformed search. And coming to the informed search, it is used for quick solutions, but it's knowledge, and in every step by step it's take more time and less complexity compared to uniform research. And these informed research like heuristic DFS nothing but depth first search and best first search and A star algorithms. And coming to the next slide, working for such search techniques, these are classified into birth first search and depth first search and uniform cost search. Coming to the birth first search, it is a most common search strategy, like this algorithm using for one by one node to node, and BFS algorithm is used to every level of it's checking every node. And also BFS search is a general graph search. It's using FIFO Q data structure. FIFO means first in first out technique. It's mostly used in first come first serve, like data structure based. And this is used for depth first search, and it this technique is it's using more memory, and and is expected more. And coming to these advantages and disadvantages of DFS, the BFS is birth for search. It's any solution we can exist that one, and also given problem is minimal solution required to the large number of steps. And also coming to the disadvantages, it's using more memory, and also more compatibility to DFS. An example of BFS DFS graph, here the start node and here the goal node. We can start from birth. For example, we have to take birth for search. It's a level 1, level 2, level 3, level 4. Birth for search goes on level by level, and depth for search it goes on directly to the goal node. This is the time complexity based on its applications is globally positing systems, and also graph biographic partialities and networks that is shared to the BFS and also DFS. And coming to the DFS, it is a traversing the every node and every level. Depth for search is a greatest depth node before moving to the next step. It's using stack data structure like a queue data structure. It's for last come first serve based on data structures. And this algorithm root node is a branch of the feasible before reversing. Due to limited resources, search is usually conducted the limited depth in search instance. And coming to the depth for such advantages and disadvantages, advantages like it's a take less memory compared to BFS, and allow, and also time is less time to compare to BFS. And coming to the disadvantages, it's go yeah, in DFS it's checking every node, so it's a time taken process, like and also it's a deep down searching, like DFS we can call as a deep down searching also, because it's infinity loop. We this is performed in infinity loops. And yeah, and also yeah, uniform search, uniform cost search. Uniform cost search is a weighted traveling source, and it expands the nodes according to their paths and cost and routes. Every node we can use calculate the using cost, like queue priority. And the coming to the advantages and disadvantages of uniform cost search, it's a less cost chosen, and disadvantages is algorithm is stuck in infinity loop compared to DFS and BFS. Example for UCF, this is the starting node and this is where goal node. We have to move first. We have to take calculate the cost, that means f of n, and also we have to calculate the cost of the node, like example we go for 2 or 5. First we calculate the cost of c of f of n, so that which one is maximum number, so the node goes to the that next level, for example 1 to 5, because 1 is the less number compared to 2. So this likewise we have to reach this goal state. And this is the uniform curve search. And coming to the informed search, informed search are A star algorithms, and also best first search algorithms. A star, coming to the A search algorithm, it is a space using heuristic functions. Heuristic functions nothing but h of n. We have to calculate the h of n plus g of n is equals to f of n. That is the fitness of number. This is a formula. We have to use the nodes calculations using f of n is equals to g of n plus h of n. This formula we have to use to calculate the every node and every level. And yeah, coming to the advantages disadvantages of a search algorithm, this algorithm is the best algorithm compared to BFS and DFS also, but it's very complex wise, it's very problematic we have to face. And coming to the disadvantages, large scale problems, because it's calculate the h of x also. We have to take a cost of search and h of x, so we have to reach every level and every nodes, because it's reaching the goal node now, so that it's take more time compared to other algorithms, but it's take less memory. And compared to best first algorithm, nothing but a greedy search, we can call as greedy search also. Best first search is a combination of DFS and BFS. Like we have to use this formula, h of n less than or equals to h of star of n. H of n is a heuristic and h of star n is estimated cost of the node. And this greedy first search algorithm is implemented then investigation of the every node, and burst search is applied the essential of determine which nearby the most promising the knowledge of the problem of the domain. And coming to the advantages and disadvantages, advantages is that DFS and BFS is a gaining advantages of both algorithms. And also coming to the disadvantage, it is stuck in a loop as a DFS, and this algorithm is an optimal. So we have to consider, most probably we have to choose a star search algorithms. And yeah, next we'll continue my teammates, Sahajapriya.
Coming to severe weather avoidance using informed heuristic search. So this is nothing but we use informed heuristic search to control or to find ways to avoid from severe weathers. Next slide. First, I need to talk about abstract. Here, due to severe weather conditions, there will be risk to flights. For example, if a thunderstorm occurs, there is nothing to do other than diverting the flight from thunderstorm. Here, an algorithm is created which takes a radar input and gives the safest way for diversion. Next one. Um, because an airplane does the majority of its work in the air, how it navigates and leads itself is highly reliant on what happens in the air. In 1901, fall weather caused at least 21% of all the general aviation accidents, and it occurred due to only bad weather. Based on the statistics, it does not appear that there is a pressing need to understand the weather and how it impacts us. With the release of the free flight, the necessity for a weather avoidance algorithm is both reliable and speedy became more pressing. Next one. Severe weather includes a wide range of weather conditions that could be dangerous to your health. The phrase localized storms is used a lot. A lot of wind shear, strong updrafts and downdrafts, or heavy rain, or all the parts of these meteorological conditions. There is a good chance that one of these things could be a lot damage to the plane. Extremely strong wind shear can break down a plane's frame. It can be hard to control airplane when it gets violent updrafts. So the pilot may lose the control of the plane and have to make an emergency landing. Because of this, the best way is to stay from places where there are bad conditions. Next one. So it has led to a search algorithm. A search is a heuristic search that is based on previous knowledge. It is a goal. The goal is to keep the total cost of the path called f as low as possible. Each node in the search tree is checked for the value of the function. The value is shown at the top of the search tree. An evaluation function and the results are two part of this thing that make it work. The first one is called g, and shows how much it costs to get to the node. The second one, called heuristic function, shows how much it costs to get from the node to destination. So finally, f of n is equal to g of n plus h of n. Next one. Um, so for developing a weather avoidance algorithm, we need to follow some of the steps. So weather avoidance algorithms choose the quickest way to get out of bad weather, but the way must also meet certain rules set by the threshold level of comfort and also amount of work set by the pilots have to do. And the physical limitations of the plane in order to work properly is mentioned in some of the references. So there should be at least a certain amount of spaces between any two points on the plane or plane route that are connected by the path vertices. This is important to keep the amount of work that pilot has to do down, as well as to let the plane finish one turn before starting the next. As a part of our method, we figure out how far two nodes are apart. Flight path should be piecewise linear and have a few turns as possible to make sure they are safe and efficient. The pilot's burden will be lighter because of this. The average number of turns in a flight path is less than 600, but the maximum number of the turns should be more than 900. So in our algorithm, we have set up a way to make sure there aren't more nodes we make from a single one. Next one. So for I would like to explain about thunderstorm algorithm, avoidance algorithm. So the steps involved in this are these steps are taken to make up the radar image uncertainties and errors. As a result, no node can build in this part of the search tree to find the shortest path between the 2 points. A number called 1 is used to figure out how long in inches the part of the path that can be reached is. This number is known as before the search starts. The segment 1 is broken up into parts based on the length of the segment and the number of turns that can be made in a flight path. Each segment is drawn on a line and that is perpendicular to the original path. Then nodes are chosen along the path of the length. It is the same depth for all nodes on the single line segment. The size of the grid determines how far apart two consecutive nodes are. The size of the area that can't be reached and maximum angle that can be turned or two limits that can be used to choose the nodes. Excel. So here is a basic situation. in which flight path is blocked in a circular thunderstorm. So putting a node of depth 1 between point 1 and point 2 won't make the shortest path go. So in order to cut down on the number of calculation, the nodes between the point 1 and point 2 should be cut out. The number of nodes that can be made of each step is limited. So start and end points are not in the storm if they are not in the search tree root node. The root node is the first node in the search tree. Using the strategy, you need to know that the storm is ahead of the plane, and neither the start or finish points are in the same area that isn't open to the plane. Next slide. For development of a heuristic function, I would like to tell about the process. In SMS star, each node has certain amount of storage space. When there is no memory and successor node is needed, the nodes that cost the most is taken out. When the procedure is done, it also removes node from the memory whose evaluation function value is greater than certain threshold value of the best forgotten path. In our case, though the search tree can never have the same node at two different depths because of how the problem is defined. As a result, the chance two nodes that look at the same could grow at different depths is no longer possible. Choosing the right number of the nodes in the final path and enough memory for them ensures the solution. Next slide. Coming to the results, some test situations are run through the algorithm that was shown in this picture. The grid size is always 1 mile by 1 mile, no matter what. In the first case, figure 1 shows a radar image of a storm that isn't moving. If you look at, you can see where you are going to land and how long it will take. The inaccessible area is calculated based on the definitions given. And the figure 2 dark area is like the radar image in figure 1 that isn't accessible. The start is at the point 1 and the end is point 2. This is how it works. After tracing the area that can't be reached, the shortest flying path between the point 1 and point 2 that avoids the thunderstorm, which is found. Next slide. So in figure 3, it shows the flight path in relation to places that can't be reached. In figure 4, it shows the flight path in relation to the radar image. The radar segment must be at least 8 units long in this case. Next slide. Figure 5 shows that a thunderstorm that isn't moving on a flight path in the second case. There is a storm on the first path from point 1 to point 2. This is shown in the diagram. The picture shows that flight path that the weather avoidance algorithm takes. So case 2 must have a minimum length of 10 units on the radar image to be called a line. Next slide. So in case 3, it has 3 stable thunderstorms in the flight path, starting at the position 1 and ending at the position 2. It is same as in the other scenarios. When the thunderstorm avoidance algorithm is used, it makes sure that the plane doesn't fly through areas where there are a lot of storms. A radar segment must be at least 8 units long in this case. In 15.25 seconds, the computer figure the best way to get there. Next slide. This is how you see the radar image as a line chart, and with the grids hidden to make the grids hidden makes it easier to read the lines. At least a 30 is above the red counter. The green counter has more than 20 dBz. The blue counter has more than 5 dBz, but it's not enough. When the plane is at the starting point at 1, the dotted line shows thunderstorm activity, and the solid line shows how bad the weather storms are. And when plane reaches the endpoint 2, there are 3 thunderstorms in a line moving at 40 miles per hour in the direction of the positive x in case 4. Next slide. If you are seeing this picture, a line of thunderstorm is moving at 50 miles per hour in the wrong direction. It also points that the starting point 1 and the ending point 2. The plain safe route is also shown in the diagram. So this is how it works. The plane doesn't go near the areas marked with the red counters or places where there is a lot of bad weather. Next slide. Coming to algorithm convergence and stability. If the path starting point in the area where there is a lot of thunderstorms, the algorithm does not figure out the safest routes. There are thunderstorms on both sides of the algorithm, so it won't be able to go back and avoid them if they can't move forward. In some of the scenarios, the suggested path comes very close to thunderstorm with a lot of power. This can be avoided by lowering the intensity of the area that isn't accessible for us. The algorithm says that the part of the map that have more than 25 dBz of intensity that are not accessible. This restriction can be increased to say 20 dBz, but it will make the flight path more difficult to follow. Next slide. So for the summary and conclusions, this approach uses A-star principle and SMS star search modification to save time and space. So the algorithm is then used to stimulate 5 different thunderstorm scenarios that results as shown. The algorithm evaluates the safest, shortest path in the limited area of the map. These modifications may affect the solution's optimality, although they are not critical now. The search tree depth is defined by the flight path number of turns. The stimulation of findings are also promising, and however, the techniques have improved a lot now. That's all. Thank you.
Thank you.